So now we want to be a little more efficient. We want to look at division with the standard algorithm, the standard long division algorithm. But now hopefully that we've done the dots and boxes, you can kind of make sense of why we start in the largest place value. Let's do the problem on the left first, 5,790 divided by 4. So we start in the thousands place and we're thinking to ourselves, of course, in the elementary class, it might sound like this. How many times does 4 go into 5? But what you're really asking is how many groups of 4 are in 5. All right, and that's 1. All right, there's one group. If there was 5 dots, you could circle one group of 4. And then, of course, there's 1 dot left over. And the way we figure this out is we do 1 times 4, right? There's a little multiplication process, and we write that underneath it. And we subtract to see that we have 1 left over. Now, we can't keep that 1 there. We have to move it over, unexplode it. And the way we do that with the long division algorithm is we bring down the next digit and we read it as 17. Well, sure, if there was 7 dots in the hundreds place, but we unexploded a dot, there would be a total of 17 there. And so we ask ourselves, how many groups of 4 are in 17? And the answer is, well, there's 4, because 4 times 4 is 16. Subtract again, there's 1 left over. Bring down that next digit, and we're reading it as 19. Running out of space, need to zoom out a little bit. So how many times does 4 go into 19, or how many groups of 4 in 19? Also 4 there, because 4 times 4 is 16. I have 3 left over. And lastly, I don't want to forget the ones place. Bring down the 0, right? How many times does 4 go into 30? And that would be 7 times, because 4 times 7 is 28. And then I'm out of digits, right? I'm finished in the ones place. So that's my remainder at the bottom. So I could write that up here, remainder 2. Answer 1,447, remainder 2. Now, when you did long division with bigger numbers, like dividing by 34, well, now we have to do some guessing and checking, because I don't know my 34 times tables. I only know it through maybe 10 or maybe 12. I don't know 34. So when I'm looking for groups of 34, I have to know, well, how many times can I find a group of 34 without going over the amount? Well, certainly in the 10,000s place, there's not going to be a group of 2. So we kind of unexplode it and think of it now as 22. How many groups of 34 are in 22 dots? Well, none at all. So you can't do that at all. So you actually have to look at 3 digits and think to yourself, how many times does 34 go into the number 220? And you might not know that, so you might guess and check. Now, you might do that off to the right, like, well, I can figure out, well, maybe I think, because 30, let's see, 30 times 7 is 210, but 40 times 7 is 280. It's just too much. So maybe, maybe it's about right. I'll try 7 and see if that works out. 7 times 4 is 28, carry the 2, 21, 22, 23. So that's too much. Okay, so maybe I try 1 less. What it would be 34 times 6. By the way, sometimes you'll see students scribbling out or erasing it. Don't do that. You might need that later. 6 times 4 is 24, carry the 2, and 204. That's going to work. So I want to put that here because I'm talking about the number 220. So I want to write my number right above that, my dividend. All right, so 6, and 6 times 34 is 204. If I subtract, I get 16. All right, bringing down the next place value, I'm thinking of how many times does 34 go into 162? Again, I may not know. I might guess. I might think, well, maybe 4. So I can figure out that's 136. If I'm not sure, I might try 5. Now, if I do that, you can see that's too much. So it's just 4 groups. 136, again, subtracting. Got to do a little borrowing. There's a lot of computation here. So I have 26 left over, bringing down the ones place, 261. And now maybe we can see why this thing that I've circled over here is very important. I can see that 238 is going to come in handy. So if I already know that 34 times 7 is 238, I can figure out my remainder to this problem is 23. So my answer is 647, remainder 23. Now I did all of that as a reminder, something we've all seen before, but let's go back and think about, I've kept these on this screen, the problems we did on the previous video where we were dividing with dots and boxes and other bases. I want to go back and examine this with a standard algorithm in those bases. But to do that, we have to know our facts. There's so much you need to know to be successful at long division. So think about teaching elementary school. You're trying to teach long division to somebody that doesn't know their times tables. It's not going to happen. If they don't know how to count, it's not going to happen. If they can't add and subtract, it's not going to happen. So here we have 2102 base 3 divided by 2. So we're going to start from the left, right? How many times does 2 go into 2? Well, that seems to just be 1. It seems pretty straightforward. Okay, bring down the next digit, 1. How many times does 2 go into 1? How many groups of 2 are in 1? Well, none. So I actually need to bring down a secondary digit and read it as, how many times does 2 go into 1, 0? Not 10. Okay, we are in base 3. So I look over at my times chart. Now, since I'm dividing by 2, I'm going to look at the line 2. I either have 0 or 2 or 1, 1. Well, 1, 1 is too much. So I can only do 2 times 1, which is 2. So I'm going to put a 2 right there. I forgot to put my 0 here. Remember, when the answer is none, you put a 0. Now I put a 2 here, and 2 times 2 is, I'm sorry, I said that wrong. 2 times 1. So I gotta back that up. 2 times 1 is 2. All right. And so I put that underneath there. Now this looks a little funny at first, like 10 minus 2, like what's going on? See, there's a temptation to code switch, but it's actually 1, 0 minus 2. And you actually have to not only be able to count forwards, you have to be able to count backwards. So 1, 0 minus 2. Now remember the count in base 3. It looks like this: 1, 2, 1, 0, 1, 1, 1, 2. But we're at the number 1, 0, taking away 2. So we would be back at 1. And so that's something to think about. All right. Bringing down the last digit. All right. How many times does 2 go into 1, 2? That's 2 times. 2 times 2 is 1, 1. And we have, our answer is 1, 0, 1, 2, remainder 1. You know that I made a few errors there. I had to correct myself. That happens. We can look over here to verify 1, 0, 1, 2, remainder 1. Got the same answer both ways. Let's take a look at the next one that we did with the dots and boxes. Now I need a base 5 multiplication chart, right? And not only that, I'm going to have to guess and check. I may not know how many times 1, 2 goes into 2, 4. Now, it looks like 2, but I might want to just verify to make sure. Is in fact 2 times 2, 4? Yes, it is in base 5. So we're good there. And then 2 times 1 is 2. So in fact, it is 2 times. And so I have none left over. Bring down the 3. How many times does 1, 2 go into 3? No times at all. How many times? Bring down the next number. How many times does 1, 2 go into 3, 0? It also will go in twice. And when I subtract, oh, do I have to be careful here? Remember, I'm in base 5. So I got to borrow, right? I borrowed, and this becomes a 1, 0. Not a 10, but a 1, 0. 1, 0, take away 4 in base 5 is just 1. Yeah, because 1, 0 is only 1 more than 4 in base 5. So my answer is 2, 0, 2, remainder 1. Once again, noticing we have a great match there. Let's take a look at the last one, which was our base 8. Have a huge multiplication chart here, right? 3 goes into 5 once. Bring down the 5. I want to look at my multiplication chart. I'm on line 3, and I want to look for what's the largest number that I can find groups of 3 in. Well, it actually turns out to be exactly even. 3 times 7 is 25 in base 8. So I'll put a 7 there. Don't code switch back to base 10. Bring down the next number. 3 goes into 4 once with 1 left over. Bring down the 7. Again, looking on line 3, I noticed that 3 times 5 is 17. And so I have a remainder of 0. Final answer, 1715, base 8. All right, hopefully we're getting a sense of it now.